A medical test has three important characteristics. Sensitivity is the chance that if you do have the disease, the test will catch it. Specificity is the chance that if you truly don't have the disease, the test will give you the all clear. Predictive value is a measure of how useful the test is based on its sensitivity, specificity, and how commonplace the disease is. Let's say that we write a test. We just test for the word error in the API response. This test has great sensitivity. Every time the bug happens, our test will catch it. But our test has appalling specificity. It turns out that lots of code in our app returns an error message, though those events might be benign or even routine. We'd say this test had a low positive predictive value. The few cases when the bug really does occur are discovered by our test. That's great, but the majority of the time that bug isn't present, and our test will be intermittently flagging that something is busted, reducing the predictive value or usefulness of that test. As you can see, sensitivity and specificity are often not symmetric. A test can be very sensitive but have poor specificity. Tests are often scripted to be sensitive to a bug, but less attention is usually paid to making them specific. The result? Flaky tests. For a fairly rare software bug, the graph of positive predictive value against specificity is highly convex. That's not the case for sensitivity. A test that has a high sensitivity and low specificity is more harmful to our positive predictive value than tests with low sensitivity and high specificity. So the intuitive approach of focusing on test sensitivity is misplaced, and it's often more important that tests are specific.